I just once you start, I will just like broadcast this workshop into like the StreamYard session to be published on YouTube.
Okay,
Okay,
we will
they will get
start.
you also. Yeah.
We will start exactly uh, five uh, at um, at five past 8.
Okay. Okay.
Great.
Also, Doctor, for the questions, Q&A, they will be they will be all available on StreamYard. So I make sure at the end of the session that you receive all of them, or if the questions, I will just copy them and post it here, like to be also to see if you can answer or and be involved in the Q&A session from the audience of the Egypt Scholar.
Unfortunately, I think the chat is not working if you are outside my organization. So just feel free to tell me immediately that there is someone asking this or that question. Maybe you can try using the chat box, and if it's working, then no problem. But I think it's not working if you are.
Yes.
Yeah. Sorry for that.
Yeah, no worries. Yeah, thanks. Thanks a lot, Doctor.
You're welcome. So I just would like to tell you that this is the third meeting. We had the first meeting. We were focusing on 3D printing, and computational material science. Maybe Rifat will join me when I say it was an idea that started during the MIT boot camp, the online course by Massachusetts Institute of Technology. So we just started speaking about material science, and we thought, why not make it internationally, so we can discuss different things and different topics.
Hello, Mahmoud. How are you?
Hi,
Nice to. Yes, you're absolutely right. This idea came out through our bootcamp sessions.
Yes, yeah, Rifat, we were together colleagues in the MIT boot camp, the online course made by Massachusetts Institute of Technology. It was great opportunity for innovation and for those that would like to commercialize the technology and bring it to the market.
Yes, it was a pleasure working with the team, like all the members, like Modi and other people who are great leader in their respective categories of workstations. So it was a pleasure working with all the team members to
Thanks,
challenge.
Rifat.
Yes.
Thanks. It was a pleasure working with you too. Okay, so I think we are ready to go. Ala, if you hear me, we can start right now. So welcome everyone. Welcome everyone to the workshop speaking about challenges of wind turbine manufacturing in Egypt. We we estimate about 2 hours starting from now, including the talks, discussions, and the brainstorming session. The agenda, we'll start with the welcoming and the introduction done by me. My name is Mahmoud Rabi. I am working at Modern Academy for Engineering and Technology in Egypt, and I will be moderating this meeting. We will have our guest speaker, Engineer Muhammad Abbas. He's a project director working in renewable energy, and he will speak with us about different wind energy development roadmap in Egypt, and then we will have about 10-minute question and answer. And then we will have almost 1 hour discussion between the attendees about different challenges and different cooperation channels that we can build with the industry. And at the end, we will announce the topic for the next meeting, and then we can maybe go for dinner or something. So, summary of previous meeting. We had the previous meeting, the last one last month was about composite materials and their use in wind energy. We spoke about different composite materials that are used to manufacture the wind turbine blade. We spoke about the design and different aspects of the materials. We had our invited speaker was Professor Mustafa Shazli from British University in Egypt, and he spoke about the last 10 years of gaining the know-how of manufacturing wind turbines in Egypt. And we started a little bit the discussion about the different challenges accompanied with such a sector. We spoke, yes, about the design, the materials, the know-how, and different aspects of that sector. We defined some early challenges and some early discussions that we would like to carry on in this meeting. And there was a wide range of attendees from academia, from industry, from companies, and from universities. It was really very nice meeting. You can see everything that we have done in the previous meetings on the LinkedIn group Innovations in Material Science and Engineering. After this meeting, I will share with you the slides, and you can just click on the link and register at the LinkedIn group. The aims of this meeting, just trying to find a way toward wind turbine manufacturing in Egypt as one of the emerging markets in the Middle East. So the area of Egypt as part of both the Middle East and North Africa can give very good opportunities and very good fields that could be useful for the manufacturing of wind turbines. That's what we believe. And we want to discuss different challenges and what needs to be done either locally or in the region in order to have some kind of an ecosystem that can support wind turbine manufacturing. What are the needed actions or policies that people from the industry could help us discussing what do they need that we can ask the policymakers about. And we aim also of building cooperation channels between attendees, so those that they have some resources and some potential that they work in the field, they can say, I have this, I would like to have that. So we can exchange knowledge and exchange experience in order to cooperate together, and finally to build and facilitate industry-academia cooperation pathways. And finally, to inspire young students and young researchers, young engineers and entrepreneurs that would like to work in that field or get inspired and decide, okay, that's something that is good for me, I would like to go that way. So let me introduce for you our speaker, Muhammad Abbas. He is a project director specialized in renewable infrastructure projects with 17 years of international experience. He worked in different fields and participated as a consultant in different projects in renewable energy in Egypt, Saudi Arabia, Emirates, and cooperated with different companies like Siemens, ABB, and Senvion. About his education, I'm glad to be graduated from the same university. He graduated from Cairo University, of course, Faculty of Engineering, but he specialized in electrical power engineering. I was in metallurgical engineering. So he's also a certified project manager, has different certificates in project management, PMP, IPMA. I'm really happy to have you, Mohammed, to have you here. You can learn more about Mohammed through the link. This is his LinkedIn profile. You can click it in the document that I will send it after the meeting. So, Mohammed, go ahead.
Thank you, Mahmoud. Thank you, Dr. Mahmoud Awad. A very nice introduction. Very happy to share my presentation with you. It is my honor to explore together the current wind situation in Egypt, and to explore together the roadmap and the history of the wind industry in Egypt. But I have a question to the audience. When exactly do you think it has started to develop wind projects in Egypt? When exactly do you think? What's your expected year for this? This is a question, by the way, to the audience.
Well, I know the answer because I saw the presentation, but I will try to keep quiet.
Is it 10 years ago, 20 years ago, 30 years ago, 40 years ago, 100 years ago? What do you think? Especially in the wind.
This is Refat here. I do believe that it is maybe between 5 to 7, 5 to 9, something like this.
This is what I was expecting also 10 years ago when I started working and looking for this industry, but it has been started since 1986 by the introduction of NREA, National Renewable Energy Association in Egypt. So it is very old. The initiative from Egyptian government that has started 1986 and doesn't stop till today. And it has a lot of projects and a very ambitious plan to develop and to grow the renewable industry, especially the wind industry. So it is not 5 or 6 years, Engineer Refat. It is very old history in Egypt. We can proceed forward.
Muhammad, yeah. When I say 7 to 9 years, I do believe it is the development. But as you know, Egyptians always come first, but the development rate is not so fast. So maybe we are old in this, but the development,
Exactly.
development, not come only recently. Yeah.
Exactly. Yes. So quickly, we will explore the potential wind locations, the current situation of the wind farms in Egypt, the roadmap of wind energy, the national policy legalizations and frameworks, the governmental support. We have a lot of support from the government in this regard, and it is worth to be shared. The advantages of having a wind farm in Egypt. The previous, the current, the future projects. And by the way, the future project is something like I'm learning every day that we have a boom in the wind projects in Egypt. The funding partners and a quick information from the Global Wind Energy Council regarding Egyptian situation of the wind. Actually, it was very difficult during 2020 in different industry, but not for the wind. In 2020 and 2021, the wind industry has actually doubled in terms of capacities installed across the world, and it was not really affected by the COVID pandemic. As you can see from the sources, the GWEC, as you can see that the installation has doubled like 50% more from 2019 till 2020, led by Chinese, of course. They are leading the installation capacities around the world, but also there was a lot of installation in the Middle East and Africa, and also a lot of installation also in Egypt, and it was not really so affected like other industries. So this gives you an indication of how the need of the wind energy was really very high, to the level that it was really overlapping the crisis and the problems generated from the pandemics, both 2020 and 2021. Look at this map. This is our Egyptian map. You can see the potential locations for the wind. By the way, Egypt is really Egypt enjoys a huge amount of wind, steady, with an average speed of around 10 meter per second, especially at the Suez Gulf area. 10 meter per second steady is like a dream for a lot of other countries, but in Egypt we are enjoying this, and it is really flowing in Egypt. We have also potential places east and western of Nile. We have a small place also in El Kharga, Oasis, and Aqaba Gulf. So all of these places is enjoying a speed of 10 meter per second. This is huge, especially in Suez Gulf. But for other places, eastern and western of Nile, the average speed is around 7 to 8 meter per second, which is still very suitable for energy generation. I can tell you also from the map. Can you turn back to brief slide? All the area in red and in yellow is a potential locations for the wind. The areas of green is not really that important for the wind generation. As you can see, a big spot there in Suez Gulf area, covering Ras Gharib, covering Zafarana, till Hurghada, where we have a lot of areas there. If you visit this place, you will find a lot of installations working already and feeding the electricity with renewable clean energy from the wind. The target, the government, the private sector, all the industry leaders is really targeting 12% out from wind renewable. This is huge, by the way. This is 6.8 giga, giving into consideration that our today's installation is less than 2 giga, but the upcoming project is huge and it will be explored very soon. This is a very tough target, by the way, and it is really giving you the clear picture of where we are heading and the volume of the projects in the very near future. A lot of investors, a lot of developers are really looking at Egypt as a very perfect place to develop wind farm projects. Gulf of Suez, as I said, is enjoying 10.5 meter per second on average speed. As you know, the speed of the wind is proportional to the energy generation. The cube of the speed of the wind is proportional to the energy generation. So we are really having a steady flowing wind of 10.5 meter. This is above the average of the world. The eastern and western part of Nile is enjoying also 7 meters, which is really still suitable for the wind farm. We have there is a dedicated area by the government of Egypt to NREA, as I said, NREA is the National Renewable Energy Association. They are the controlling governmental authority for the wind industry in Egypt. And this area, especially in Gulf of Suez and the Nile banks. The combined capacities today is more than 1,000 megawatts. Look at the first point, we are targeting 6.8 gigawatt. We are now producing more than 1 giga. So see the difference in the target and what we are now. So I said to you, it is a very tough target. But there is a plan to add another 1.3 or 1.4 mega in the region of the Gulf of Suez. And the plan, by the way, is a realistic plan with a lot of projects running or a lot of projects under the development phase. This is a closer look at one of the oldest places of wind farm. This is Za'farana. Usually, this is what you will see when you go to Ain al-Sukhna from Cairo at your right side. A lot of installation has been conducted in this area since 2000 at 8 stages, making it one of the most dominant area for the wind project in Egypt. Za'faran has several stages, and a lot of bodies has participated, and a lot of manufacturers and developers has participated in the development of this area. And it is really was a very successful installation. And the capacity has reached in this area up to 500 megawatts. Continue, please. Yes, Mahmoud. Mahmoud, can you just return back to the slide for with the bar graph? Yes. This is the evolution of the no. The bar graph, Mahmoud. تمام. No.
Which paragraph you mean?
The bar chart.
This one.
Yes. Read it. Yes. As you can see that the installation was around 500 megawatt till 2014. After 2014, there was like a gradual increase, steady increase, like 30% every year. And that has a reason because in that year, there was a lot of legalizations and a lot of support from the government. And at that year, it was also like a trigger for the developers to come and to invest in Egypt in several projects. And the result was immediate results in 30% increase every year. And a huge number of projects has been signed and came into force starting from 2015. And the reason is at that year, there was a new way to think about the grid, electricity, the electrical grid in Egypt. That year, we have liberated the grid, making the IBBs. IBBs, this is the power producers from the private sector. We open the door for them to be able to come and make investment, especially in the renewable industry. and by introducing the new electricity law. This law has opened a lot of opportunities and motivated a lot of developers to come and make the investment, and also has changed the electrical grid, the way we are looking at the electrical grid. Before this law, all the projects, most of the project was especially for the generation and renewable industry, was all belongs to the government, and it was very difficult for private companies to participate in the development and the installation of such type of projects. After this law, the new electricity law, it was easy, it was manageable, and it was really seen as a very important opportunity in Egypt from local and international developers to come and invest and to put the first brick in developing generation projects, especially in the renewable industry. Back in 2007, as I said, we started the renewable by introducing NREA in 1986, but in 2007 there was an ambitious plan to set a target of generation capacity from the renewable industry, from solar, from wind, from geothermal, from hydro. And the wind was really the majority. It was like 12%. And the target was to produce up to 20% from renewable. The target was to generate up to 20% electricity from renewable industry. And to achieve this target, there was a lot of steps has to be taken from the government. The steps was like designation of areas, changing the laws, motivating developers, finding partners to fund the projects, giving facilities, changing the way we are looking at the electrical grid in Egypt, and it was really a very important step. And this was the introduction of the wind map as presented to you early. And from this wind map, it was clear to everyone that Egypt has a potential to generate up to 30 megawatt from the renewable. And from this step, it was really important to note that the industry has changed in Egypt, and the focus to generate from renewable was visible, and developers has noticed the potential in Egypt. The current supply is 9% from renewable, 2% from hydro, and 7% from wind. Continue. As I said, that we have a law in 2015, and this law has gave a lot of support to the industry. The feed-in tariff system has been introduced. As I said, if you have a good funding, then the opportunity to motivate developers to come will increase. So the Central Bank of Egypt has to guarantee the obligation of EETC under the power purchase agreement, and that was really important to give trust to developers that Egypt is really willing to buy the power generated from their wind farms. And also there was like a stipulated form to sign the power purchase agreement up to 25 years, and that was huge. give also some advantages for the renewable, especially as the custom duties, reduction in custom duties up to 5%, dedicated area for wind energy project, and this area is around 1,228 kilometers square. You should practice agreement to give trust to developers to that the land will be acquired by them for 20 or 25 years till they finish this the power purchase agreement with the government. Permit of the land was convenient and easy to be obtained. The carbon credits, any project will be able to get benefit of carbon credit, and one of the most important challenges in Egypt is the bird migration. You know, the area of the Gulf of South. This area, because of the high wind, birds used to fly freely over this area and migrate from Europe to Africa and vice versa. The birds in this area, they are migrating in groups and in different seasons over the year. Building a wind farm in this area is exposing the birds to a lot of problems. Imagine a bird flying and get hit by the wind turbine. A lot of and thousands of birds may die because of this, and this will generate a lot of environmental problems. And for this, the bird migration study has been prepared by NREA in cooperation with different international consultant, to avoid or mitigate this problem, or to reduce the problem to the minimum. Of course, there was an important to get support from other ministries, and one of the most important support is the investment ministry, the GAFI, and there was a lot of regulations to let the developers create the company and get licenses to be able to generate the electricity and sell it back to EETC. And it was really very difficult in the past. Today, it is really recognized as an important shape of companies, and now the developers can easily create the vehicle and the company for such type of project, because it is now facilitated by GAFI. We have learned a lot from the school that Egypt is in the middle of the world, and it is true. We are really in a very good place. We are enjoying a lot of connections to Europe, to Asia, to Africa, and the government was really clever that it has established a lot of commercial agreement with Europe and with the COMESA in Africa, and a lot of agreement also in the Arabian Gulf. By these agreements, Egypt is really heart of the area, is now considered as the heart of the area. Only the remaining is to get people motivated and to get developers to invest in Egypt, and it is really now going into the right direction. I hope this will continue because the area and the place and the location of Egypt deserve huge changes, deserve huge remarking from different places, because really we can change the areas we are interacting with, and we can really get benefit a lot from the proximity and the commercial trades and the connections. The history of the wind in Egypt started, as I said, not before, not 1988. It is started in 1986 by introduction of INRIA, and then the first pilot, 4 turbines, small type, 100 kilo each in Ras Gharib. Second pilot, Hurghada, it was 5.4, and then Zafarana. Zafarana was really, it is not okay. Zafarana was really has transformed the industry from small scale to utility scale. As I said, it has been established into 8 stages, and the capacities was there since 2000 till 2010. But that time, the development of the Zafarana area was from the governmental efforts, and the addition of the generation capacities was into 8 stages, and now the generation capacity is really bringing like third of the high dam capacity. So imagine now we are over 545 megawatt in Zafrana area. Then Ras Gharib area. Ras Gharib area, it is a very potential area for private sectors. A lot of projects are running now, and a lot of projects under development and under construction in this area, and it is very potential. This is like the phase 2 of the areas of the wind farm in Egypt. As I said, it is very interesting area for private companies, and we are expecting a lot of gigawatts to be installed in this area. Engineer Rifat, can you give your question, please?
Yeah, I was asking, I mean, the total now of Zafarana capacity is 0.5, almost GW, I mean, gigawatt? 0.5 till now? I mean, the overall total?
Yes.
Okay.
A lot of installation already has been done near Zafarana and in Ras Gharib. Adding, as I was presenting, adding capacities that has reached another 500 mega. So the total now, if you took a picture today of the number of the installed capacity, it is exceeding 1 giga, 1.2 giga, and a lot of capacities is about to come this year and next year. A lot of capacities, by the way. So the target, I believe, we will reach very soon 2 giga before the end of 2022. The current working project, Ras Gharib wind farm, energized. The manufacturer is Siemens Gamesa Renewable Energy. West Bakr wind farm is about to be energized also this year. This is 250 mega, and also by Siemens Gamesa Renewable Energy. Future generation, as I said, we have a lot of projects coming in the pipeline And what I was trying just to list here, what is really in my mind. So we will reach 6.8 gig very soon. It is very difficult, but it is coming. And the potential of the wind in Egypt is really booming. And the future projects includes, today the development of more than 2 giga is running. EMEA Power, this is the Emirati company, 500 mega. Enrea wind farm, 250 mega, and it is with Vestas. The consortium of Orascom, NG, Toyota, they are having a 500 mega, and they have completed, as per the last presentation, they have already energized the 250 mega. Today, I have learned also that we have 500 mega coming from Siemens Energy, under development and under studies today, and we have also 200 mega coming from a lot from Infinity. So a lot of projects are coming, and I'm trying also to count them for you, but the problem is the information is not so available. So very soon I will update you in the group by the number of upcoming projects. Yes. We have a question here.
Hi. So, hi. This is Mohammed Ataya from LM Wind Power.
Hello.
Hi. So these are all good numbers. How about the storage policy here? So energy, like wind is wind. If wind blows, we are in good shape. If not, then we cannot afford to run out of power. So what is the storage policy that the government is taking in parallel to cover this expansion? 9% is an appreciable number. So
and yes, if there is today, if there is no wind today, there is it means that there is a drop of 9% from the grid, and this will shut down all the grid.
Exactly. Yep. So what does is there a clear government policy on storage policy? How the grid is reflecting?
I take your question.
Responding to
very
this?
good question. I think your question is a very good one, and I was discussing the same with our colleagues from different developers like Tequila and Ras Gharib, and I hear that there is a discussion of providing storage facility in the new installations, but so far the installation in the pipeline is coming without storage.
Okay, so it's feeding the grid directly without any storage capacity. Okay.
Yes.
If you allow me, Doctor, to just jump into this question. I'm Dr. Maged Mahmoud. I'm the Technical Director of the Regional Center for Renewable Energy and Energy Efficiency.
أهلا بيك. أهلا بيك.
أهلا بحضرتك. And in fact, the storage option is on the table, but this is an option for the entire grid, not only for wind projects.
Yes.
And already there are now ongoing studies for pumped storage facility on Ataka Mountain, and this is 2,500 megawatts, which would be, in fact, in the vicinity of the wind farms on the Gulf of Suez. And it's, in fact, the concept is to use the renewable energy power there, in fact, wind mainly, and also solar in the near future, to use this to feed the pumped storage facilities. So this is one option. There are other sites being explored right now for the pumped storage option, also in Upper Egypt and in other places. This is one side of the equation. The other side of the equation is that up to right now, worldwide, there are two approaches to solve this issue of intermittency of renewable. One of these solutions, of course, is the regional interconnection. And this, although the capacities now are not that much, Nevertheless, there is a pan-Arab electricity market that would be created within few years, which would allow us to use higher capacities for renewable. And also, there are some objectives to somehow export to Greece and Cyprus and so on. This is one side of the equation, which will take, I would say, I wouldn't say this would be on the short time frame, but would be on the mid to long time frames. On the other hand, together with this, the issue of converting the grid to become a smart grid, and in fact, the flexibility of the system. Hello, can you hear me? Yes.
Dr. Megid, the voice. Can you just repeat because the voice was interrupted?
Sorry for that. I'm saying that the other way to, beside having interconnection and beside having storage capacities through pumped storage facilities, and in the future also maybe through batteries, is to have smart grid. And to have a smart grid, there are a lot of activities being done now to modernize both the distribution and the transmission systems to allow better response to the fluctuating nature of the wind technology. Nevertheless, it has been proved worldwide that up to 15 to 20% wind, it doesn't make a lot of a big issue to the grid, especially when you have this distributed over a wide area of that does not have the same wind pattern within the same time, which is somehow not the case for Egypt, but let's hope for the best. The final solutions that I'm sorry for taking long is the trend to use the renewable electricity whenever available for I would say other demands, like for example feeding hydrogen, feeding electrolyzer to have green hydrogen, and this is also now being discussed widely, not only in Egypt but in the entire region for the future of wind and solar technologies. Sorry for taking long, but just want to reflect on this important question. And thanks
thank you, Mr. Meg, Dr. Megid. Thank you a lot for enriching the discussion. It was great. Allow me to recap. So we have now four solutions to guarantee or to proceed with the storage, the pumped storage in Jabal Ata'a, and the connection with the transmission connection with original transmission connection with Jordan and Sudan. And we have also smart grids to be able to adapt itself with the changes in the renewable generation. And what else? The fourth one was
the use of the electricity as is, whenever it's produced, to produce hydrogen, which can be stored in ammonia.
Yes, electrolyting extracting hydrogen. Yes,
Power solutions.
Yeah.
Yes.
Thank you, Dr. Noel, for your participation. It really was very wonderful one. Thank you.
Thank you.
We are expecting like an investment of 1.9 billion as US dollar funded by different entities for projects project under construction or even under development stage.
Thanks.
The funding partners, as I said, Egypt now is really on the radar for many funding partners. Some of them are old, like EBRD and IFC, EIB. Some of them are new, like KfW, JICA. In REA itself, they are funding them a lot of projects in Egypt, and they are funding a very good project, 250 mega, with Vestas, and other upcoming projects also are coming from INREA and French Development Agency. Those are the lenders, the current lenders in the market of the wind industry in Egypt. Do you think that we have more lenders in this list? Does anyone have any?
Think, they are already a lot.
Yeah. Okay, continue, Mahmoud, Doctor.
Yeah. Yes.
The perspective from Global Wind Energy Council for Egypt is the investment will be doubled. It is even will be tripled till 2022. 3.2 average gigawatt capacity is expected to be added in Africa and the Middle East in the next 5 years. The drivers of the growth in the area is South Africa, Egypt, and Morocco, Saudi Arabia, and the Middle East. That's it for yeah. I'm sorry, I forget this one. Another nice graph showing the evolution of the wind and the perspective till 2025. Today we are like 1%, but we are expected to be growing 2%, 3%, 4% with the growth of the total renewable energy itself. This is a macro data giving a perspective of where the industry is going. The industry is going towards huge growth in Egypt and towards new installations every day. So thank you a lot for your support and your questions and enriching the discussion. Now we are opening the questions and receiving answers from the participants. So
thank you, Engineer Muhammad. You are very much in time. Now we can have 10 minutes discussion about any questions generated from this talk.
Engineer Rifat?
Anyone?
Yes.
Yeah, just a follow up for my last question. When I asked the total capacity of the Zafarana 0.5 gigawatt, and do we know the total capacity for the wind turbine overall in Egypt now? How much?
Around 1.2, and very soon will be 1.4 for a new installation, which will be very soon into the grid from Likila West Bakr project.
Yeah, so my understanding now that the government has a delay, or you can say come late on their achievement. If their target is 6+ gigawatt in 2022, correct? If I
It is tough target. It is tough target. It's a very tough target, and to reach this target, it is like a target just to get attention of everyone, to the region, to the country, and giving
you mean that it is not real attention?
If you allow me,
it's real. They have the intention to bring a lot of energy from wind in Egypt. It is real, and they have introduced a lot of, as I said, regulation and legalization, and secured a lot of lands and funds. So I believe it's time.
Do you expect that they may reach this 6.5 in, for example, 3-4 years?
I believe we can reach it even before.
Okay.
In fact, the target, the 6 gigawatt was an old target. This was announced with the strategy of 2008. And this was based, in fact, this is a translation of the percentage of the generated electricity at that time based on the big demand expected in 2022. Nevertheless, what happened in reality with the reform of the electricity sector, in fact, instead of having 6 to 7% annual increase in the electricity demand, Egypt now is somehow between 1 and 2, and in the last year it was even not reaching 1. So the reality that if you compare to the peak, Egypt has reached already 20% from its peak demand. So this would give us some relaxation. Also, if you are aware, of course, that we have already surplus of generation capacity of around 20% now or more, which in fact is another factor that we should not rush into, I would say, projects without having them as much as economical and in fact, as studies as much as we can. Nevertheless, we would achieve. I fully agree with you, Dr. Mahmoud, that we will reach this target of more than 6. In fact, the target up to 2035 for the entire renewable energy share is 42%, and there are studies underway to have it up to 46%. But now the confirmed number for the Egyptian government that within the coming 15 years, the renewable energy share, that total, I mean, solar and wind and others, would be 42%, which is much higher than the 6 gigawatt that we were aspiring to.
Yeah.
But to correct 6 gigawatt with the target, in fact, of 2008 that we announced. In fact, I contributed myself when I was at NREA at that time to this target. But this is not the current target.
If today the big demand for electricity, as I remember, is around 28 gigawatts. So and we are now producing 1.2 gigawatt from the grid, from the renewable winds, a total of more than 3 giga from renewable solar and hydro. This is giving a perspective of reaching like 12 or 13% from the demanded
the total renewable capacity are 6 gigawatt now. 3 gigawatts hydro and another 3.2 solar and wind.
Great, yes.
So 6, if you calculate this 6 over 30, let's say, but it's lower than that, So you can imagine the number now.
It is, yes, 30, I think, this is like 20%. Yeah, Dr. Megdad?
Yes, this is what I'm saying, yes.
Yeah. 20% renewable, and the target has been reached. The number is giving you. I was just adding the number just to give you a perspective of the upcoming project and the demand. I know we are having, by the way, we are having extra generation capacity. That's why we are doing a lot of projects to sell electricity to other countries. Recently, we built a connection with Sudan, and we have already an established connection with Jordan, and there is a very ambitious line with Saudi Arabia. All of them will participate in evacuating the energy generated from different sources, especially from the renewable, and this will really maximize the advantage of renewable generation, especially in Egypt. As I said, we are really enjoying a very good potential from the generation of renewable in Egypt.
This is Mahmoud Rabi. Dr. Maged Mahmoudi, you spoke with me earlier also about the fact that onshore is getting less and less and more focuses on offshore. Do you think this also affects the wind energy spectrum and sector in Egypt, that no investors would like to invest more in offshore and not onshore? Do you think we are affected with that, Dr. Maged?
Okay, first of all, let's agree that the decision on having wind or solar projects now is purely economical, and with the renewable energy and in fact solar and wind technologies are already cost competitive when it's for onshore facilities, and that we have excellent wind regimes, and we have in fact a lot of vacant areas that we can use onshore and then solar technology on. So in fact, those who go for the offshore goes for 2 reasons. First of all, that they have shortage on available land that can be utilized with good wind regimes, because the cost impact, the higher cost of at least installation cost, and then the maintenance cost for the offshore compared to onshore. This is one reason. The other reason is, in fact, to have higher generation, which would somehow compensate the extra cost. But nevertheless, we are still and please correct me if any of the attendees have better numbers, we're speaking about a cost of kilowatt hour that is still almost double of the onshore facility. So when you are taking the decision, you go first for the most economical solutions. I wouldn't say that this would affect the appetite of investors to come to Egypt for wind technology. In fact, whenever we announce for a pipeline of projects, in fact, investors are rushing into the Egyptian market. And this is because of many reasons. The first is now we have the confidence of the investor that they will get what was promised, whether it is the electricity prices, when they bill us for the tariff and so on, and regarding the interconnection, and regarding also I would say, the regulatory and the institutional capacity to support them. This is one thing. The other thing that we have already in Egypt, I would say, partners. I mean, from the private sector that would support the installation of the project. I mean, with respect to the civil work, roads, excavation of land, even electrical work with cable laying and so on, even supplying the cables, parts of the transmission systems and so on. So they have already local partners that would allow the installation of the project and supplying part of the component up to 20% right now from the local market. So services and some of the components are sourced locally. If you bring this to having finance from the international community, from IFIs, international financing institutions, that really trust Egypt and they are willing to finance private investors or private developers who would like to invest in solar and wind in Egypt, then you would have the right equation to attract investment. So it's a part of de-risking of the investment. So I wouldn't say that there is a problem of attracting investors or a problem of resources or a problem of land availability with respect to wind. The real issue here now, whether to maximize the benefits on the local economy out of this, I would say, expansion of wind energy in Asia. And this is, in fact, what I'd like to hear from the distinguished participant in this today webinar, how they see the future of value creation with respect to the industry itself for local manufacturing and for others. Because, in fact, this is really not clear as part of the equation. And if we look into other countries, for example, Morocco, we would say that they are requesting a local content criteria. And they are requesting, for example, establishment of a local factory for blades. And they are, whenever they increase a target, they would like factories for other components. And so for Egypt, what is the perspective? This is what I'd like to hear from you, whether we are able or not to do, and especially if we have industry colleagues attending with us.
Okay, a very good question. Thank you, Mr. Magid. I was really also aiming to place this question on the table today. What is the possibility to increase the local percentage of manufacturing for the turbine? This is really important question. Thank you for this. I have some answers. As I used to work with Senvion. Senvion, it was a good German manufacturer for wind turbine. They used to be like this till 2019, and then they disappeared from the market. I can say that in Egypt we are having a lot of opportunities to build a wind farm with a very big percentage from the local industries. As you said, the cables, the civil work, the roads, the substation. However, we still have a lack of the technology itself. The technology of building the turbine, the nacelle, the blades, the connections, the electrical connections inside the nacelle. But apart from this, all other things like steel towers, cables, electrical distribution, ring main units, substation, all are available and produced in Egypt, by the way. Can be available in Egypt. But we are really not we are not having the technology for the turbine itself. And if you are targeting 6 giga, if you are targeting 6 giga in the very near future, then this will really must be translated into finding a new industry in the wind and really deepening the wind industry in Egypt by making the blades and the nacelle locally in Egypt. It is a dream, but it has to come true, especially if we have such big opportunity only in Egypt. I'm not saying for other places around us, which is, by the way, not reachable from Egypt. But if you have 6 giga or 5 giga or 4 giga, this is a very important target for companies really looking for technological investments in Egypt. But also, this has to come with more support from the government. It is not far from this.
دكتور محمد عطية تفضل. you can maybe you raise your hand, you can ask your question or your comment.
I had a couple of comments. So the first was on that mix of electricity that we are targeting, and whether we factored in the contribution of the upcoming Daba nuclear reactor, and how will this change the picture? Here we are talking about a very robust and stable addition to the grid. And as Dr. Magid pointed, the problem we are facing now is that we are overproducing, and now we are like reaching to Cyprus, Greece, Saudi Arabia, North Africa. We are trying to sell this. So if we are expanding today, what will be the picture in 10, 15 years, especially with a major addition in terms of the nuclear reactor to the grid? So that was one question, and the other it pertains to the wind atlas. I think it was shown in the early in the presentation, and I'd like to understand better, like, why are certain areas in Egypt, like those green areas per se, why are they not suitable? Is it wind speed? Is it the turbulence or the low wind speed? These are the two questions.
Okay, I can answer the first one, or at least participate in the answering of the first one. What is really the future of the expansion? If we put the question in the right, actually during the last 2 years, there was a lot of projects appointed for expansion in the fossil-based generation of electricity, like gas and coal. But recently, and it was really clear that the direction of generation in the government now is to replace all the fossil generation by renewable. For example, in the list of the upcoming projects, there is EMIA Power. EMIA Power belongs to Illinois Investment. This is an Emirati company. And in Illinois, they were planning to invest in a coal plant, generating electricity from the coal. And then has been agreed that, okay, we are not making electricity from fossils or coal, and instead of this, we will sign with you a wind farm of 500 megawatts instead of generating. So as you can see, this transition from coal generation to renewable is giving you the answer where we are heading. We are heading towards a more of renewable and less fossil generation.
Nuclear is different. Nuclear is a different story. I'm particularly asking about Daba, because nuclear is relatively clean. Well, it is actually very clean. If we are doing our job properly and not messing up, not like nuclear is all or none basically. But France has been running nuclear for 50 plus years now without any operational incidents. So the question is, if I end up with multi gigs of additional kilowatts, of additional watts into the grid, how am I going to dispense those? Who are my potential customers?
Yes, but part of the question is the demand itself. The demand is expecting to grow a lot in Egypt. And the efforts made to link the electrical grid with other countries like Sudan and Saudi Arabia, and increase the capacity of Jordan line, and to have a link also with Libya and Cyprus. All those efforts is also to evacuate the generated capacity coming from renewable. So it's like a financial model. If I am able to generate with this price and able to sell it to others with this price, then this is a profit for me. So it is not only just to how I evacuate the generation, but also how to sell it to others.
This is
I can tell you also that, but it's not confirmed, but a lot of investments coming to Egypt in the industry, in different industrial sectors, and one of the conditions coming is a percentage of generation to be renewable. So this is also another driver. Mr. Magid can illustrate this for us more if he has more information about this.
Okay.
So
I'll answer the first question. Whether the strategic plans have considered nuclear or not as part of the energy mix, and with respect to the expected demand. Of course, you are better than me, professors, that there are extensive modeling exercise that see how are the projections for the demand and what are the expectations for the, I would say, costs versus demand and so on. And nuclear has been part of the equation, also called for the previous study, and then the I would say the best feasible system for Egypt is now considering 42% percentage, including nuclear and renewable, but excluding coal. This is a reality now. And this has been announced by the minister himself. I'm not, of course, I'm from intergovernmental organization where I'm not representing the Egyptian government, but I'm saying that when we spoke with Excellency and also the officials from the ministry and from NREA, it was clear to us that no longer coal in the table. Yeah. Nuclear is planned among the energy mix of Egypt due to several reasons that we are all aware of. And renewable is, in fact, a major contributor to the future energy mix of Egypt, but up to till now 42%. And the remaining 58% are nuclear and the existing conventionals, as you know them. And this is the growth that we are seeing. This is the answer of the first question. For the second questions, I have not, I'm sorry, I missed the part. I missed the slide on the solar atlas, on the wind atlas. But in general, the exclusion areas are typically because of the low wind regimes. This is a standard condition, and we are speaking here about what we call also the economic wind speed, the lowest wind speed that we can use. Of course, the turbine can operate at 4 to 5 wind meter per second, but when we are speaking about the economies, it shouldn't be less than 7 meter per second on average. Yeah. Less than that, and this is called a site class 2, which is not the best. Of course, higher than that, like in the Gulf of Suez, would be higher. But the solution if you are having lower wind regimes, like for example on the west of the Nile, you go for higher elevations, you go for higher towers, and then instead of the maximum limit that we have on the Gulf of Suez, which is around 120, 130 meters, you go for higher than that, and then you capture more wind.
Yep.
But in general, the main, as you said, this was a right and correct remark, that the limitation mainly is the wind speed. The other limitation is what we call exclusion areas. And the exclusion areas are that when we do several layers when we are doing the what we call micro setting analysis. And when you do this, you exclude, for example, the areas that have rainfall areas or baths for within the
flood
within
zone.
the area.
Okay.
Around flood zone, yes.
Yep.
Or you would have areas that are used, for example, for other higher value and the economic or better economic activities, or protected area, for example, you cannot use wind there. So there are several exclusion criteria, and then based on that you reach the site that you select for. And this is why Nerea, part of the presentation was the incentives that Egypt gave to wind energy. And in fact, one of the key factors that attracted investment, that we de-risked the investment with respect to the selection of land. So NREA has obtained more than 12 permits for each piece of land it is allocated for wind now. You can imagine that you are taking the permission of, for example, the Ministry of Oil and Gas, Petroleum, Ministry of Petroleum, that this area is not now on the schedule for oil extraction. And if there will be coordination. We are taking the permission of the Ministry of Tourism and the heritages, and you know how important and this especially in the areas for Upper Egypt and Wahat and so on. You are taking the permission of the Ministry of Agriculture that this area is not, and so on. And in case there are conflict of uses, somehow they reach an agreement on what to do in such case. Like the agreement reached on the border of Egypt on the Gulf of Suez, although this is an area, what we call a border area that have restrictions, they agreed on some measures that would allow for the height of the tower to be limited to 120, which is fine for the current technology. And for the Ministry of Environment, they were refusing to install wind farms in certain areas. And then there was a program, which I'm proud that RICRI, my center, the Regional Center for Renewable Energy and Energy Efficiency, have proposed, which is called the Advanced Turbine Management Program, that would allow to stop the turbines whenever you have a migratory bird in certain time through a sophisticated system that we have established. And this system would use not only radars or visual impact, but a lot of tools together to ensure that not a single bird is dying out of this through that 2 seasons.
Is it already working now, this system?
Yes, it's working, and it is in fact, without this we would never have acquired financing from the international community, because financing is conditioned to have a full respect of the environmental regulations, and part of these regulations is to protect the migratory birds. And in Egypt, we have more than 0.5 million birds each year coming to Egypt, resting in Egypt, and then flying back everywhere in the world. 5.5 million, 500,000, and this in 2 seasons, in the spring and on autumn. So this is some sort of Hajj, like the birds are resting in Egypt for a while. So what I'm saying, that the exclusion areas are based on several criteria. Among these criteria, for example, is the proximity to the grid, and how much would the transmission line would cost. And so we are selecting the priority areas based on this also. And there are many. I'm sorry I'm taking long, but I hope I have answered the 2 questions. Yes, nuclear has been considered while planning. The second, that the exclusion criteria is based on many issues, but the most important is the wind regime there. Mainly the wind speed.
So, I think the problem is not, like it's a multi-factor problem. It's an optimization problem. The solution that we have where I work, we have the low wind speed sector, basically, or low wind speed class of turbines. And as you pointed out, the solution is to go higher. So all the 70 plus meter blades will go into this. This is the model that is more prevalent in Southeast Asia. And I'd say like India, Bangladesh, and other countries in this region, because they do not have, like, everything there is below 7 meters per second. So these blades in particular, because like this is like the aerodynamics of the blade, designing the airfoil, and the length, like the rotor size. Here we need to capture as much energy as possible from this low wind speed. So this is the solution. So at least in terms of the optimization problem, designing against different constraints, there is a solution if the wind atlas is to be revised soon. Definitely it translates to other factors, transportation, grid, tie-in, etc. But there is a baseline solution to start from, at least.
I fully agree with you. Fully agree.
Yeah, I would like also to talk about my previous company, Senvian. They used to have a very good product, a very good turbine, very perfect for the Gulf of South area, because at the height of 120 meter, they can produce up to 3.6 megawatt per turbine. Compared to competitors, it was 2.4 megawatt. So that time, Senvian was really a rocking star, and unfortunately, it didn't continue in the market. But hello.
If you allow me to comment from the materials point of view as a material engineer, and also having a little background in entrepreneurship, you were speaking about what we will do when we have more capacity and we have more generation. From my point of view, I see an opportunity for building more factories and more industries, and to build an ecosystem that can use this extra energy to produce something that we didn't produce before. Like, for example, semiconductors, like 3D printing factories, like many industries, maybe that more steel producers, more aluminum producers. And we hear now that the prices for these metals are going up and up. So it could be an opportunity from my point of view, that plus exporting the energy to Cyprus and to Greece and so on, we can also use it for building regions near to wind farms that can produce industrial products that requires more energy. What do you think?
I would talk, at least from my perspective,
Yes.
building blades, glass is more of it's becoming more of a standard, like a mainstream industry. And it is still an energy intensive solution, like fabricating glass fibers. But the more impending question here is the technology transfer. This is the problem. Like having the energy, that is fine. This is very important requirement. Having the know-how, that is a much bigger question. If you recall, like last time we spoke, like Dr. Shazli mentioned that the infusion trials, the resin infusion trials, it took them 2 years. And this is not out of the ordinary, basically. There is no textbook that will give you answer to these questions. If you go and follow the textbook, good luck.
Yeah.
This is all trial, error, improvement, and end of the day, you end up with your secret recipe. That's why this is an industry secret. And I didn't mention carbon fibers. Carbon fibers, like this is really a secret sauce. There is no textbook that will give you the key how to manufacture a successful roll of carbon fibers. So
I have a question in this. Okay, so I always say that the blades is having a lot of technology, but the nacelle itself, it is like assembly of a car. There's no secret sauce, this is, as per my understanding, it is only to build to bring together quality parts from different places and assemble it in Egypt, like what we are doing in different industries, by the way. So is it visible also in the wind, or it will not be visible at the current stage, or the current generation, or the current capacity? Or do we have an opportunity to invest in this technology, in the cell technology? Because as per my understanding, by the way, there was a lot of trials to build a local wind turbine, by the way, especially by Sweden in Egypt.
Yes.
And they started already with a very the most easy part, which is a steel tower.
Yep.
And they made a very good factory, and this factory was working, by the way, till and it was very important factory in the design of the project, purchasing and supply chain. But they stopped at this stage. They didn't continue. They didn't build the plate. They didn't build the nacelle. I know that they were having a plan, or what I can say, a dream to do the assembly for the same, but they stopped. I don't know the reasons, and also I don't know the history, but it looks that it was difficult because an important investor in the industry like the Sweden is not able to continue his project. So it gives you the impression that it is not that easy, as I believe.
I would look into the economics. So I spent like 2 years working on towers here in looking into offshore towers, basically, for the Haliad X turbine, the 12 megawatt turbine. So we have issues to the construction and maintainabilities of these towers with the bolted joints. So we were trying to find like some crazy solutions. So the problem with towers is size matters. So like if you are following the market now, like manufacturers started to look into additive tower, like site built additive towers, because there is a constraint on how big of a shell you can roll and weld. So now we are building 4.6 meter towers at the base. Okay, and this is for the, I would say, for the for onshore, for the 5 megawatt class turbines. In our terminology, like within GE, that's the Cypress platform, the Sierra platform. The problem is the game is never stopping. So we are pushing for bigger rotors and longer towers. So this will translate immediately to bigger diameters. So the question for Sweden or other local manufacturers is, what are you targeting? What sector are you targeting? Are you targeting like an export solution like the Indian manufacturers or the Chinese? Or are you targeting local building? This is the question that Sweden will have to answer. So that is one piece of the game. The other piece is, while tower, you are dealing with metals and everything, but it still requires a significant degree of technology. If you don't want to follow Eurocode construction and use the material properties listed there, if you want to establish your own database, it's not a cheap process. you will have to do testing, very, very comprehensive testing programs to qualify your material. This is an added cost. And if you don't do it, then you have to abide by Eurocode curves and material properties. And this will has its consequences in terms of the efficiency of the design and construction.
True, yes. And challenges are getting, it's a game and it never ends. And every day there is a new height, there's a new technology, and it is getting difficult and difficult more after day. Even it was an easy part like the steel tower. So yeah,
exactly. Vestas Vestas responded to us by putting the 15 megawatt turbine, and probably I can tell it like we are talking now we are looking into the 21 megawatt platform, which is still conceptual. So this is still like scribble in pencil, but there are I think we are hitting soon we'll start to hit physics laws in terms of cooling and other issues that are far beyond building bigger and more powerful machines. We are really hitting material science laws. So anyway, I mean, we are still growing big, and I think it's still on the upside, but the story is getting more and more difficult.
Is there an opportunity for local manufacturers to compete in this?
Excuse me?
Is there any opportunity for local manufacturers to compete on this, or the best way is to team with, to have production, the reality? What would be to get into this market? So instead of doing it ourselves, let's borrow the technology and do it under license for other market. Would this be feasible?
I would say it has to start from somewhere. We cannot reinvent the wheel. We have to start from some seed technology or some existing technology. Exactly. We have the manpower. I work LM/GE wind power. We have our big, one of the biggest bases in India, in Bangalore. So I feel I taught in Egypt years ago. I know the system, I know the caliber that we have, and quite frankly, this is an everlasting question. Why are we not doing this? We have a very strong caliber, and all we need is to have the knowledge transfer, which does not happen overnight. So
the only market penetration in my mind is to get an old technology adapted in Egypt, fully adapted in Egypt, and to work with this technology as a start till you build your own technology. Like the Korean, when they started the high voltage system, and because I'm coming also from this, they started taking the older design from EBB and Siemens and build the factories to make equipment, high voltage equipment, with the old technology, and they sell it. They were able to sell it to different countries, especially the Gulf, with a very good prices because it's an old technology. And then now look at them. They are now building very sophisticated high voltage products, able to compete the edge technology at EBB and Siemens, and they are competing with the good prices by the way, because they started in this way. So I believe that the same penetration strategy can also works for Egypt. To start with an old technology, a turbine with a maximum of 2 mega, 3 mega, and to be able to build such type of turbine and to install it in a places where the maximum need is only 2 or 3 mega, and then you grow up. This is the
We have a question or suggestion from Dr. Mahmoud Ahmad Hamdi, or would you like to to go ahead?
Yes, please. Hello. So, thank you all for your awesome talks and very helpful information. But there's one small correction I want to say. I'm a student, an engineering student actually, not a professor or doctor. So there's one thing that I want to ask.
Now you became the doctor of this session. Okay, enjoy it.
Thank you. As a student who's interested in wind energy, there are extracurricular activities and even some curricular activities that encourage students to design parts or entire wind turbines. But it's not really clear for someone who wants to penetrate the market. What skill sets should they obtain? What should they learn, etc.? What even are the roles that are available in Egypt? If I want to enter the automotive market, it's pretty much known what I should do, but if it's wind energy, it's really unclear, especially for students. So can one of the experienced participants help out on that?
Well, that's actually was going to be my next comment. So commenting on the previous questions, that's me, Mahmoud Rabi. We need to build some kind of ecosystem in Egypt. I searched a little bit about why India and China is more favorable for the investor to build their investments and factories and so on. So there are many factors that should be playing in this. Part of it, what you're saying, that we need to have courses dedicated in the educational system in universities and after the university in continuous learning. For me, as working in undergraduate education, it's very important to include such a part in the curriculum. Very important, not only the curriculum, to have practical experience for the students, so you can graduate with the experience about that. In the previous meeting, I pointed at some courses that are some trainings in Egypt that are dedicated to renewable energy. I can share it on the group after the meeting. But
that
also,
would be awesome.
Yeah, but also to go back to the previous question, we don't only need the education, but also to build different industries. So for the wind turbines, no one will manufacture the wind turbine from A to Z. So you will need to buy certain parts from other manufacturers. Until now, one of the biggest challenges that everything is imported in Egypt. The material for making the wind turbine, for making the blades, most of the material is imported. Most of the spare parts, the generators, everything is imported. So we need to gradually build the ecosystem for other factories producing this, and then we can say confidently, okay, now it's very easy to have a factory for wind turbines that can get all these parts from near manufacturers in the same area. It doesn't have to be in Egypt, maybe Egypt, Saudi Arabia, Morocco, but it's near. So it could be an ecosystem in which many parts can cooperate. This is my personal point of view. Maybe the doctors and the engineers can correct me if they see other ways. I see also from the attendees many people from the educational system and from undergraduate and graduate education. Maybe they can give us a comment. Is there a course in Faculty of Engineering that helps the students to work in renewable energy and especially wind energy? If anyone can comment about that. So maybe it's a bit tough question, but I think there are some opportunities, but it's kind of difficult to find. And the opportunities for for cooperating in order to build such an ecosystem is not a one step or one man endeavor. It's something that many parties can contribute or could contribute to, including also the government making the policies that can help such collaboration.
If you allow me,
Yeah, please.
the question in its current format is a bit, I would say it needs to be sharpened. How? The wind industry, in fact, is an industry that includes many aspects. And when we speak about planning, it differs from speaking about those who are working on the project implementation, on those who are working on the supply of components, and so on, or those who are working on the testing and certification. So, each part of this value chain, I would say, requires a different set of skills. Of course, you need to know something from everything on this entire value chain. But at the end, when you specialize, each part of this is a different, I would say, a different story, a different, a full different way of thinking. For example, if you are one of the wind farm planners, you are learning many issues related to the wind regimes. You are also learning a lot of issues related to how to position the wind turbines, about the roughness of the site, about how you deal with obstacles in the site, how you calculate the distance between wind turbines, which technology would be preferable, what types of soil investigations, and so on. And then you are using specialized models like the WASP, like WindPro, like others, and you should be really clever in that. But this is different from those who are working on the design of the turbine itself. For those who are planning, they are taking the turbine as is, based on standard catalogs for this turbine. But for those who are working on the design of the turbine, they should be very much, and I mean each part of the turbine even is a different story, but they should be really qualified in the aerodynamics. They understand the issues related to material stress and so on. Each part is a different way. And this is in fact a question for all engineers. We are learning in the wherever we learn, whatever the faculty we learn in, and whenever we learn the basics and we get an idea about. But to be specialized, you need to decide which part you would like to be in, and there are opportunities everywhere for those who can excel, and there are opportunities to learn and then to work. But it depends which part of this system you would like to be in. So,
yeah,
in fact, we should teach our students how to think, how to get to decide on their own which part they prefer to get in, and then the knowledge is there. And for the curricula to study, there are plenty of curricula. For example, in Egypt now, there is what is called the WESET project being implemented by Ain Shams University, the British University, and I assume a third university that I cannot recall now, maybe the Arab Academy.
Yes, actually, I'm cooperating with them in one of my projects, actually. Yes.
Yes, they have centers of excellence dedicated to wind technology. And they have, I would say, laboratory test facilities and equipment for different components in each of these universities. And they have also standard, I would say, very well prepared course materials for postgraduate students and undergraduate students. What I'm saying is that the knowledge is there. Who would like to learn would go deeper and get the knowledge. But that's the question, which part of this ecosystem you would like to be, in fact, master in, you would like to master in, you would like to be professional in. Whether to be a professional or to be a researcher this is my comment. I'm sorry for taking long, but this is
that's great. That's great.
Thank you for your answer. It was actually very useful, and it will definitely take. I mean, it's not really a clear answer, but it's what one should do. I will spend more time looking into it and looking into what fields are there, what specializations are there. So thank you. It was helpful.
You're welcome. We can show you the door. You're the one that has to go through it. Quoted from one of my favorite movies. So unfortunately, we are almost at the end of the meeting. I thank all of you for participating, for the wonderful discussions, for everything that you've discussed. Please put your comments if you have more questions about the topic. If you have any more comments, please put it. Ala Salim, please go ahead.
Yes, Dr. Mahmoud. Yeah, sorry. Thanks a lot for your fruitful talk and for this conversation. I'd like just I got some questions from Egypt Scholar, the group. So if it's possible, like share like just 2 or 3 questions.
Yes, please go
Yeah.
ahead.
Yeah. Thanks. So yeah, we got here. First question was like asking about, do the vertical axis wind turbines shown in the next few years in a larger scale? This is the first one. And the second one, I wonder if the offshore wind turbine will be installed along the coastal zone of the Mediterranean or Red Sea.
Yeah, maybe we can take each question one after another before we forget it.
Sure. Yeah.
Dr. Iman al-Mahallawi, welcome. You want to comment about this question or?
No, Dr. Mahmoud. I actually wanted to answer a question that you have previously asked. So maybe you can go on with this one, and then later on I can. Okay?
Okay, great.
I shall wait. Okay.
Yeah, okay. So I'll try to be brief. So there are many ideas about innovative other ways of producing wind, but unfortunately they didn't prove good capacity until now, like the vertical axis wind turbines and so on. I had the pleasure to have this discussion with Dr. Magid earlier, and he explained for me that until now it's not really viable that we can use it. It doesn't work. You invest for 20 years, so you have to do something that is not only for research that can prove just for a few years that it's working, and then you have to assemble it. So you have to use something that is there for a long time.
Absolutely. I will from an industry perspective, I think the case is closed. We are doing horizontal axis wind turbines, and we are doing 3 blades.
Yeah.
We can think about single blade, 2 blades, 6 blades. All these are fine as mental exercises. Business-wise, horizontal axis wind turbines, 3-bladed. Period.
Great. And what was the other question, Mr. Ala? The second question.
Yes, it was. I was wondering. Offshore installation exactly on the coastal and the Mediterranean. The coastal Mediterranean and Red Sea.
Could you repeat the question, please?
Okay, there's a question that I wonder if there is an offshore wind turbine that will be installed along the coastal zone of the Mediterranean or the Red Sea.
I'm not sure if I'm qualified to answer this question. I'm not sure if.
Let me answer you. At least from the Arab countries' perspective, till now, the announced plan mostly depend on onshore. We have not seen a single wind farm on the Arab region that is based on offshore technology, and this is because we have a lot of coastal area that is even have not a single inhabitant there. Nevertheless, we don't know what the future would bring with respect to the technology, because the offshore technology is moving very fast worldwide. The prices are getting lower very quickly, and so maybe we would see a different story within the coming years. But till now, and in the based on the announced targets and the announced plan and the pipeline of projects, all of them, if I can say, if I'm not missing any, all of them are onshore.
Okay.
And financially, the offshore is very expensive, very, very expensive, and no single financial model can work in Egypt, or even as said by Mr. Magid, or in the very, very cost, requires a lot of tools and procedures, and and even I can tell you, we don't have the knowledge in Egypt to install such type of projects, offshore projects.
And plus, as you have shown in the wind map of Egypt, we have already lots of good places that we can make onshore, so we don't need that much to go to offshore. That we have very good potential areas.
Great. Yeah, great. Thanks.
Is there a third question?
Yeah, just like the other students were wondering if you can share. They heard like groups, like a kind of a link group or a courses a link that could be shared for the students and engineers to take deep into like the preparation for manufacturing of science materials. So that would be great if you can share it with us, and I can just post it on our page and the YouTube.
With pleasure, of course. But you said manufacturing of what exactly?
Wind turbines, yeah.
The turbines. Okay. Yeah. I will try to share all the data that I have, and if someone else would like to add to this, they can add it to the group or the link of the event on LinkedIn.
Doctor, I have a final comment here with respect to vertical axis wind turbines.
Yes, please go ahead.
Yes. In fact, we have to distinguish between the market for utility scale, large scale projects that are based, the plant that are established on mega scale, megawatt scales, that like what we have now. We have heard today about 500 megas, 250 megas, and so on, megawatts, I mean. And those who are, for example, for a farm or a residential area that have windy locations and can be installed. And there are possibilities for vertical axis wind turbines. Nevertheless, they have not yet reached the maturity to become a commercial product I would say, that are prevailing in the market. But there are trials on that. So those who are thinking of working on these vertical axis small scale wind turbines, there is no problem at all in that. And they can do their best, and they they should be aware of the niche market that they are working in. It is not the utility scale, it is not large scale projects, but it is for decentralized solutions that would benefit many rural areas, for example, or similar situations. So this is not to stop those who are interested in this sort of technology. No, they can proceed, but they need to be aware that they are working for this niche market, decentralized small-scale turbines.
Yeah.
Thank you. This is a very good addition. Thank you.
Do we have a benchmark for this? I mean, a company that is specialized of this type of projects and still financially healthy, or at least still doing job, because I can see that it is very weird that every time from the wind industry itself, the manufacturers are getting bankrupted that easy, and for small type of wind turbine, it is the number of bankruptcies increases. So is it really financially? Do we have something like this, like a model like Vestas, but in small scale turbine?
I'm not aware of that personally, but I'm not the expert in this domain, the small scale wind turbines. And this is why I said it is not yet matured as a commercial product. I'm sorry. This is why I'm saying that we cannot feel this product in the market. You can feel the PV system that are used for large scale or small scale. You can even feel the micro hydro now that are coming into Africa. But unfortunately, the small scale wind are not that much sensitive. Even if you look into the global status report for wind technologies, for renewable energy, GSR, you will not really see this coming as a pattern or as a trend. This is a situation now. Nevertheless, this does not mean that those who are interested to the research on that stop doing the research. No, they should continue, and maybe we can have some breakthrough through our young scientists here.
Dr. Iman al-Mahallawi, would you like to say your comment?
Yes, actually, Dr. Mahmoud, yes. First of all, thank you very much for organizing the event. And I'm sorry to join later because I had another event with my postgraduate students. Actually, I heard your question and I thought that some students would answer it, but when no one answered, then I'm going to answer. Yes, there are courses on the undergraduate and postgraduate level taught in Egyptian universities where the students would have an idea about some topics related to renewable wind energy. And actually they may learn according to the expertise of the professor about the manufacturing or about the building of the wind turbine itself. This is on the teaching level. On research level, yes, there is heavy research ongoing, at least in the two universities I know, which are the British University in Egypt and the Ain Shams University, which are members of the WASIT project group. And yes, there are, let's say, significant amount of research ongoing there on wind energy, in addition to the research about the wind blades and the manufacturing of the wind blades. The third comment I wanted to make is that when we talk about horizontal axis three-bladed wind turbines, this is for the commercial scale when we think about wind farms. But actually there is some, let's say, trend that's ongoing, that's going to actually to flourish during the coming years. I can tell this from the funding, European funded projects working on small scale for little villages, for farms, for refugees camps, for for applications which they call stand-alone and off-grid. And whenever we have the situation of we don't have high wind speeds, and in this case, I think that we would need to move from. Would look for alternatives. I'm not saying to move. Of course, the large wind farms will stay there, but we should look for alternatives which could capture low wind speeds and could be of, the prices, of course, and the commerciality of the project. Still now, this is to be investigated. But the idea itself of being able to produce small-scale energy from small-scale wind turbines, I think this is going to be considered because the European community has put several funding projects are announced during this year for such projects. Thank you very much. Okay, thank you.
Thank you very much. This reminds me was also the work of Professor Mustafa Shazli that he presented last month, and that the British University is producing wind turbines for Rif al-Masri, the Egyptian village, and it would be extremely interesting if we can lower the cost, the initial cost of the standalone wind turbines. Yeah, it's I find it a very good opportunity. Rifat, would you like to ask your question?
Yes. Thank you so much, Mahmoud, for giving me the opportunity to ask, and also congratulations to the panelists and all the team. Very insightful discussion. As I'm from Bangladesh, so I really want to know anything about the insight regarding the bladeless wind turbines, as we are getting the European countries, like the innovator, like leaders, Vertex, they are researching on bladeless turbines, and it takes less areas of land for small scale of industries like farming and other manufacturing companies, industries to generate power plants. power generation. So what is your thought on that part? Please explain.
For small scale manufacturing, right?
Yes.
For wind bladeless
Yes.
wind turbines. Yeah. I think Dr. Magid spoke about it, that it's for the big companies, they prefer not to go in that, but for standalone, as Dr. Iman al-Mahallawi was pointing at, it